Hi everyone. Am I audible? Okay. So we'll wait for a couple of more minutes and then we'll get started. Is my screen visible? Okay. First of all, thank you so much for joining this session. This is my very first live session on YouTube, and pardon me if I face some issues in terms of few things because this is the very first time I'm doing that one. I'll plan to conduct such sessions in a long run where I'll try to cover a lot of topics starting from system design, data engineering, generative AI, DevOps, and many more areas. So in this session, we will try to understand some of the important aspect of system design and software architecture, and in further future sessions we'll go very deep in that. Now, is my screen visible? Is my PPT visible? Is this Instagram system design diagram is visible to you? Okay, sounds good. So if you see this diagram, right now I'm not going into the very detail of this diagram, but at high level, before first of all, we need to understand that why do we need to learn system design? What are the different blocks in system design, and how should we proceed about the system design, and what are the different tech areas that we need to understand before thinking about going for any system design or designing a system. So if you see this diagram, in this diagram, if let's say if somebody doesn't have any back end knowledge of some of the components related to CDN, DNS, blob storage, DB search, so it will be very difficult to understand this diagram. And moreover, at high level everybody understand what Instagram does in terms of functional requirement. But if you talk about non-functional requirement, where we talk about scalability, as you know, the Instagram deals with 2 billion plus users. So scalability is the major area where they need to make sure that as the system is growing, they should be able to meet and they should be able to provide that great experience. And then other factors related to consistency is there, replication is there, and security is there. So basically non-functional requirements are also there. So whenever we go for a system design, we have functional requirement and non-functional requirement, and then there would be certain components which would be required to design a system. Like if you think about any large systems or social media system that we talk about, there will be very few component that will be required in each of the component, each of the system design that we are going to talk about. So first, let's say if you are going to talk about YouTube, Instagram, or Facebook, we are dealing with massive amount of users, where we know that we might be dealing with a lot of kind of data. It could be data could be of different type. It could be structured form of data, it could be semi-structured form of data, or it could be unstructured form of data as well. So structured form of data means when you are dealing with tabular form of data, where you might have to maintain some logical information in a structured way in a typical SQL databases. Some of the examples could be user related information or financial related information. Semi-structure kind of information, where you want to have some level of structure, something like a metadata, something like a you want to maintain some cataloging, you want to maintain some you want to maintain something like comments or feedback, or unstructured form of information, something like media or raw text. So that means you need to maintain all this kind of information. If you are dealing with if you're dealing with a global audience, then you need CDN also, you need load balancer also. So a lot of components are there which would be required for any system. Now, that's why first, before moving directly into system design or designing a system, one should have a strong foundation in lot many areas, that areas that we are going to cover. So this diagram is was just to this demonstrate that there are lot many pieces which are at the back end, where one should at least build their strong understanding in terms of building blocks, be it functional or non-functional requirements, and then some of the core components which would be required to cover a couple of architecture, some architecture pattern. Only then somebody can think about designing a system. Because until unless if someone is not able to understand what my queue is doing, where I have to place my queue, where I have to make a use of CDN, why I'm DNS is coming into picture, or if I have a scenario where I have to I have to do some searching on my platform, then search based systems are required. Or even I have to maintain some you know I have to maintain the data, and then sharding is required. I have to maintain a lot of information where distributed computing would be required. This is a very small view. Other things related to security will come into picture, other things related to DevOps will come into picture, where your containers, Kubernetes, and a lot of things will come into picture. But that's why it's very important that before we go into that direction where we think that we need to design an architecture, or you see any architecture and you are not able to understand. So the very first thing is that we should talk about that strong foundation, that how we can start any strong foundation. If we are in early in career, then I'll talk about the high level roadmap, that how should someone start. And irrespective of the experience that you have, you need to understand that if you have 10 years of experience, then you need to work on these areas. If you are starting in your career, you need to focus on this area. If you are in 15 plus years of experience, then you need to cover on this area. So I'll talk about those areas before going into that direction, that what exactly all it takes to build a system like Instagram, YouTube, or Netflix, or Facebook, or any even massive amount of system, massive amount of data where we are dealing with, and we need to think of a lot of scenario. So we'll talk about all those things, and then we'll talk about what is scalability, what is consistency, how we can achieve consistency, what is CAP theorem, and all those things. Sounds good? Sounds good. So I would appreciate, since it's a one way channel where I'm talking, and then I'm in a I could only see the chat. So humble request is, wherever I when I ask for some confirmation, please do the needful, because otherwise while teaching any concept, I might not be in a position where I'll be able to see any in the chat or something. If there would be few questions, once I'll cover some technical topics, there would be few questions. So what I'll do is, once we'll be able to finish some kind of agenda, then in that case, then I'll cover up the question. Otherwise the flow will break, and then since audience is at the very various level, in terms of we have few few one who are just starting, few ones having 15 plus experience, so it's a mixed audience. So it'll take some time to everybody to come on the page. And I could also understand, based on the industry experience, some of you would be related, some of you might be able to relate that what exactly I'm talking about. Some of you might think that it's like bit advanced for me. But what I'm going to cover is, first of all, high level roadmap. If you're in the tech industry, if you're starting, that how much effort and what kind of effort that you have to put in your career, if you want to stay up to the if you want to stay ahead of the curve, or if you want to really want to learn cutting edge content, and you want to grow in your career. So first thing first, if you see this one, this tech roadmap, is this visible, this tech roadmap? Okay, sounds good. So if you see this roadmap, and this is not a very exhaustive roadmap, trust me, based on my understanding, based on my experience at high level, I have created this roadmap, and I had floated this roadmap number of times on my LinkedIn LinkedIn account, through LinkedIn, because this is very relevant, and this is very much in need, especially who are very high in career. So if you see, whenever we start our career, everything in our world starts with the programming. So it may vary, that maybe Some might start with C, some might start with Java, some might start with Python, or even in DevOps, some might start with shell script or other scripting language. But sooner or later, somebody has to start their career in programming language. So first thing first is that if you're early in career, at least you should build some proficiency in one language, be it any language. If you are in data world, I would suggest Python is the go-to language, because Python is very easy to use and a lot of libraries are there, and especially in data science, most of the things are developed in Python. So if you are in data engineering, you might start with Python. It's not like Scala and Java is not there, but Python being very easy and a lot of frameworks, and especially the data science world is in Python, so it becomes very easy. And if you are in data world, then SQL is also must, though I haven't mentioned. So SQL is very much required irrespective of data world or any field that you have, because whatever the work that you do, be it in microservices, be it in app side, or be it in big data, or be it in anything, so you have to deal with the data. If you have to deal with the data, that means a database will come into picture. And most likely in most of the situations, SQL databases will come into picture, where some level of CRUD operation you might have to do. But based on your role, it may require that you might have to come up with the complex queries, you might have to do some analysis, and so other things. So I would suggest at least one should have one proficiency in one language, be it in Java, Python, Scala. And one should, if somebody is not comfortable in SQL, one should definitely start their things in SQL as well. I haven't mentioned Unix here. Unix is very important in our world, because if you see, most of the things are in uh, most of the work that we do in productions or in our day-to-day work based on the Unix environment mainly. Like, it could be distribution could be different. Some are Ubuntu based, some are CentOS based, some are REHL based or otherwise. But at the back end, it's like Unix. So if you're not comfortable in Unix, at least you should do your hand dirty with Unix, because be it in container, be it in Hadoop world, be it in Spark, be it in other things in terms of DevOps. So you have to deal with Unix. So if you are not comfortable with Unix, you should try your hands in Unix. Unix is very easy, and a lot of other things, frameworks, like if you deal with some Hadoop related utilities or database related utilities, or other good frameworks related utilities, most of their commands are very similar to the basic commands of Unix. At least one should be very comfortable with Unix. But if you are in mid in career, so I would suggest, even if you had got exposure in one programming language, at least one should have a comfortable with two programming languages. It could be anything based on your experience that you have. Now, as you move, if you are starting, then basic first thing is you think about your code, you think about your module, and you think about basic your design pattern, that how you have to structure a code. Your code should look good. At least basic checks in terms of code reviews, some of the tools that I'll be covering. But you can rely on the some of the code tools for improving your if you improving your coding in terms of your how you're writing your code, be it like check style, how in terms of find bugs, or other things, where based on certain rules that you can rely, where you can try to improve your coding in terms of, because at the end of the day, when we work in a team, so usually it's a process. Then you commit something, and then somebody would review your code. So if you're doing a very basic mistake, then somebody who's reviewing your code would think that you don't know how to write a good code. And whenever we work in a company where we have to think of all the scenarios and all that. So at least basic sanity of the code, or basic things which are required, where you see that these are the very basic things required in terms of basic exception handling or cyclomatic complexity, or if you're dealing with threads, or if you're writing your variable name. A lot of things are there that you can, with the passage of time, that you can avoid if you're using right tool. But yes, there would be certain things, deep things about your code, where maybe somebody, your superior, would be able to guide you, that this is how your code can break in terms of their function knowledge. But at least when you start your career, you should be very you should take care of the things, that how you write your code. And when you are think about code in your early career, then it's not about writing your code. You also have to think how you have to package the code, because it's not your single program that will run in your production. There'll be lot many dependencies, lot many other things that will come into picture. So in terms of your packaging, be it like Maven or right from the Git, you should be very comfortable that how you have to interact with Git. And then basic CI/CD steps in terms of be it Jenkins or GitHub Actions, which is very much relevant in the market. You need to understand that basic how you have to design a workflow, and then basic tools in terms of be it like Git, be it like Maven, be it like normal bugs related thing, your check style, find bugs, PMD plugins. Or if you are dealing with if you are into Java world, then few things related to how you have to do the how you have to do the benchmarking, how you can do the memory profiling, how you can do the performance analysis in terms of JMeter or something. And these are the very basic things which would be required when you are early in career. When you move into your up in the ladder, so how one should start? If you are early in career, just try to go deep as much as you can. But as you move up in the ladder, in this industry, so apart from the depth that you have, you should try to cover breadth. Because as we go up, it's not specific to that one module that you'll be working, that you'll be working on a project, you'll be working on a architecture where mix of technologies would be there, mix of architectures would be there. So until mix of databases would be there, mix of other components would be there. So that way, if you are not very well versed with your breadth, then you might face some difficulties. So if you see in architectural pattern, there are architectural pattern and there are architectural characteristic. So I'll cover lot many things in my future session. But if you see in architecture pattern, usually you would have heard about if leader follower, master slave word that we don't use, but leader follower, if you think about most of the things, maybe it Kubernetes or Kafka or Apache Spark, Hadoop, all these follows the leader follower, where you have a leader and then you have a followers. So actual work, or a you could say the work master worker, where the actual work would be done at the worker level. So master will just take care of all the nodes, all the processes which are running, and will keep on redirecting that what need to be happening. And then we have microservices, as we know. So microservices are not microservices has, so there are few things that I would say has totally changed the tech world. So one was when industry started moving towards this virtualization, cloud tech concept came, then containerization concept came. Microservices and container both contributed, where both are closely related, that microservices has contributed to the success of container, and container has contributed to the success of microservices. So microservices are everywhere now. It's not very specific to any domain. Most of the things, if you talk about any big system that you talk about, be it like Amazon, Netflix, or any thing, or even in the companies that you're working, you would have seen that most of the companies are using microservices architecture because it has a lot of benefit. I don't want to go in debate that where some companies are even moving from microservice to monolith system. Generally, if you have a very complex system, so microservices architecture gives you a lot of things in terms of lot of flexibility. You could choose multiple tech stack. Like for example, think about Amazon. So if you have to think about Amazon has lot many microservices. So some component might be written in Java, some component might be written in Python, some component might be written in Go, some component might be written in other languages. They have a lot of flexibility. There is no single point of failure. So in monolith, what happens is your all the complete system will be part of one layer, where if everything goes into one part of any system, your system may go down. So for that one, let's say you have lot many microservices. If one part of the system has some problem, then it will not affect the overall system. And if you want to scale one part of the system, then you have flexibility. So you have a flexibility to choose your tech stack, you have a flexibility to choose your deployment cycle, you have a flexibility to choose a lot many other things. So that way microservices have lot many things. And microservices architecture itself has a lot many component, where API gateways are there. You have uh, you have caching layer, you have databases, you have service registration, monitoring comes into picture, distributed logging come into picture. So a lot of other things are there, which I will cover in my future session. So microservices are everywhere. And similarly, publisher subscriber pattern is very common, or producer consumer. If you see Kafka rules the streaming world in multiple ways. be it in microservice or in real-time streaming. Kafka is a de facto standard. Similarly, like other solutions like RabbitMQ is there, few solutions in the from the cloud like Kinesis is there, Event Hub is there, Google Pub Sub is there. So a lot of things are there from publisher subscriber. So wherever you see a pattern that you need to maintain a distributed queue, that there would be some producer or there would be some publisher or multiple publisher and there would be some consumers, so you need to have this one. And moreover, when we talk about async communication, so we'll talk about that. But async communication is where you're not blocking that, where operation, like let's say if you're dealing with, if you're on Amazon, and sync operation would be, let's say you want to purchase iPhone. Now first you go and do search iPhone, you will be able to put it, search it, and then once you do it, you put it in the cart. That is your sync operation. The moment that you are put into cart, you are going into cart, you are doing payment. So until as your payment is not through, you are not able to do anything. That means your operation is happening in the sync communication way. Once your payment is done, so you would have seen, then you might get some notification at the back end that you have placed a deal, you have placed, and then some logistic services would be there where they'll, so that will happen at the async level, where where they are not blocked. Once you are done with this work, then at the back end some email notification service is there which will send you notification, and then at the back end some logistic service is there which has got the notification that now this particular product need to be shipped here and there. And now you like this phone, and you want it to review on Amazon.com. So the moment that you will write it, it will not happen instantly, because it may happen that at the back end there is some kind of filtration is there, moderation is there. They'll see that you're not using any offensive language, or you're not using any bad language. So that is also happening at the async level. So wherever async will come into picture, your this publisher subscriber will automatically come into picture. And then we have layered architecture where you have multiple layer, you have UI layer, you have backend layer, you have at the backend, and then you have business layer. So layered build again, then you have event driven system. So basically there are many architectural pattern, but at least one should understand as you go, as you move forward, at least one should understand two three major pattern that are quite evolving. And then we talk about architecture characteristic. Then comes from architecture characteristic, security will come into picture, your consistency will come into picture, whether you need the strong consistency, whether you need eventual consistency, your scalability will come into picture, and other things will come into picture. So these are related to architecture. And these are the soft skill which are required in a career. It's not about that when you become an architect, or when you go into that position, that only then you need certain skills. So right from the very first day, few things, soft skills are very much required in our career, whatever the role that you're doing. So first thing is that you should be able to take the complete ownership. You should be able to communicate effectively. At least whatever the work that you're doing, you should be able to exhibit your work. Because if your communication is not that much strong, then someone will take your credit. Suppose you have done some work, but in terms of customer, if you're lacking in your communication, then someone else will give that demo, and he'll get that kind of exposure. So at least basic level of, I would say, communication should be there. Then teamwork and basic in terms of collaboration is very much important, because if we work in a team, we need to get where there'll be a lot of points, there'll be a lot of situation where you have put a lot of efforts, and you're going for a review but someone is challenging you. Then one should take it forward, one should take it very positive, because when once you will step into that shoe, you will also feel that when you are thinking about a product, when you're thinking about the architecture, then you think about lot many other aspects. Maybe with the passage of time, someone will get that skill, but that would be there. But if you are an architect or something, then you might have to do some POC, so hands-on could be there. Leadership and mentorship, as we grow career, we need to groom the talent in terms of, you might have to help them in resolving their bugs, you might have to help them in resolving their production issues, you might have to help them in improving some of the performances in their critical areas, or improving the existing tech stack from migration from one tech to another. So a lot of things here they are there. But if you are in tech, so that's why the breadth is very important. Because if you are not going to cover the breadth, then given a chance, let's say you are, some kind of tech stack is there which is running in your org, and you want to upgrade to the new tech. So if you are not very well versed with the breadth, you might not be able to do it. Plus, if if your system is very legacy and facing some problem in terms of data or timing or other thing, so if you're not very versed with the other technologies which are there, so you might not be able to do it. So that's why with the passive time, breadth is very much important. Now I'll take a pause. Are we going good? Are we going good? Okay, cool. Now, so if you see, these are the basic things. Now I talked about couple of things that, irrespective of the the domain that you're working, irrespective of the company that you're working, there are few things which I strongly feel one should try to explore, whatever the area that you're working, if you haven't exposed that one. So some of the things are container and orchestration I talked about. So containers, if you see, containers have become the fundamental part of any modern software development and deployment. Be it any company, most of them are working something, most of them are doing something in containerization. They might be using dockers, or if they are into very deep, they might be using kubernetes as well. So a lot of things are there, but if you don't have any exposure, I would suggest at least one should have a very basic understanding of how container works, what is the problem that they have tried to use, why they have totally changed the game, how they are different from the virtualization, why they why everybody's adopting that one. So that way the containers are very much important. And then the cloud offering, uh, most of the companies are, some companies are, they might have something on their on-prem system, they would have dedicated system, but most of them are what they are doing. So they have a strong presence on cloud. It may vary, that maybe some companies very strong on maybe heavy on aws, someone on azure, someone on google, but at the back end they are on the cloud. So irrespective of the experience that you have or exposure that you have, one should have a basic fundamentals on cloud as well. Be it any cloud, I don't have any preference, whatever the whatever the cloud that you're working on, but try to learn cloud from that perspective, that you should try to think, not, you should not focus on the service, you should focus on the fundamentals. Like if you talk about storage, if you talk about compute, if you talk about networking, if you talk about gen ai, if you talk about devops, so given a chance you should try to understand that how this particular cloud is solving this problem, what are this benefit, and given a chance, if you have to move from one cloud to another cloud, then you should be able to map, okay, this particular service was doing messaging queue for me, okay, I have to use a similar services on azure, what kind of service it is offering. I was using ml ops on azure, now I have to use similar ml ops kind of services where I have to maintain the complete machine learning cycle, what kind of services there in in aws, and what are the trade-offs, like why aws was way better than azure, or azure has a competitive edge on this one. So that way you should try to understand. If you are new to cloud, a lot of people or a lot of students comes to me when I go to their colleges. They say that, how should we approach cloud, like how should we try to do that one, does certification makes any difference, uh, would it help me in career, would it help me in getting my job? So I would say that if you're striving for a certification, uh, just for the knowledge, then it will definitely help you. Suppose if you want to learn cloud and you're not doing anything, so that means you should try to maybe book a slot, you should pay for that one, maybe 4 months, 5 months, and then you'll be very serious that, okay, now I have to prepare for that particular cloud, be it any cloud. Then you will first read about that cloud, you will try to do some hands on, and once you will do some hands on, at least some fundamentals would be there, and once you'll get a chance, then you'll be able to relate it. So I would say that the very first thing is that if you want to, if you're very serious, then you should strive for certification. Certification helps you in validating your knowledge. Don't crack the certification just for the sake of certification. This certification is very common. Like, it's not like you have done certification and somebody will give you that. The only thing is, maybe your resume might get shortlist, and but your interview skills, or you will be like able to you know an interviewer should be able to judge you on the basis of the knowledge that you have, not the certification you had. It's not like you have a certification but you don't have a knowledge. Even if you have a knowledge, then even without certification it will work. But at the end of the day, what really matters is one should have a at least basic fundamentals on any of the cloud. Be it, based on your experience. If you are in early, you can offer a dev kind of certification. If you are in uh, infra thing, then you can offer a infrastructure. If you are in generic, you can think for a architecture perspective. Beat any word, but you should strive for a certification uh, to get the knowledge. Then we talked about couple of tech as totally changed the market. So if you see the very technology that has not only changed the tech landscape but also the day-to-day life, that is generative AI. So after this chat gpt, the large language model, which came around 1.5 years back, it has totally changed the game. It's not like it has only like the kind of work that we are doing, it has expedited the work. The way that we used to work, that has been changed. It has also changed our day-to-day life. As a creator, I leverage a lot of this LLM for creating my content in this way. I try to use it for getting the schedule, I try to use it for other things. So it has changed our day-to-day life. Even for a normal human being, if somebody has to write an email, even not technical, it can take a help of chat gpt and get that one. As a student, it is very beneficial where you want to learn something. With the help of this large language model, you can learn the way that you want. If you're not able to understand the concept, you can go, you can change your prompt, you can try to play with the prompt that try to make me understand in a, as a kid, make me understand in a better way, or give me more example, real world example. You can create your roadmap, then you can follow the roadmap, and then step by step you can follow that one. If you are in tech, you can if you are in like a higher position, you can try to create even a lot of I would say technical content based on the prompt that you're saying. So at the end of the day, a lot of things are there. Even we can generate lot many code from this system. We can do the code reviews with the help of AI. We can convert from text to ppt. We can generate queries, we can do a lot of analysis. So if you see in day-to-day life, as a engineer or as a in a tech also, that has totally changed so many things for us, that it has improved our productivity. There are a lot of things we were doing manually. With the help of AI, we are able to do it. We are able to solve a lot many problems within the org. So that just Gen AI. So if you are new to Gen AI now, then I would say that one should definitely spend a lot of time on Gen AI, because this is the thing that is gonna stay. And Gen AI is not that much difficult. It's just some of the fundamentals need to get covered, in terms of what are vector databases, embeddings comes into picture, how LLM is coming to picture, how we are going to retrieve that knowledge, how we are going to build that knowledge, how we are going to do the prompt engineering. So all this basic knowledge is required. But Gen AI is one such thing. Even whatever the domain, whatever the experience level you have, you should try to leverage Gen AI, or you should try to build your foundation in Gen AI. I'll take a pause now. Are we going good? Are we going good? Okay. Now, if you see other systems like distributed, if you're in, if you're in a data world, if you're dealing with large amount of data, then one should be comfortable with distributed systems like Kafka is there, Apache Spark is there, and Apache Hadoop was also there. So where you are dealing with not one system, we are dealing with many systems. And moreover, the when we talk about the big systems, like we have to design something like Netflix, something like YouTube, or something like Instagram or tiny URL, the problem is beyond the capacity of one computer. So I'll talk about distributed system after this slide, but distributed systems are there. And then basic things like, CI/CD should be there, cloud design principle, then, some of the fundamentals on cloud, serverless related technologies, basic component related to load balancers, CDN. So these are the basic things which are required as we move. It's not like very exhaustive, but some of the technologies that I talked about on stress, these are very much important in our day-to-day life. If you are early in career, then, design principle I talked about in pattern, where we need to think about some of the design patterns, or uh, you know uh, related to, like, if you're dealing with SQL databases, then ACID will come into picture. If you're dealing with no SQL databases, with CAP theorem will come into picture. We'll talk about that. And some of the tools that we are already talked about, if it is related to coding, then uh, related to, like, Git is there, from Maven is there, SBT is there, Findbugs is there. If you have to deal with APIs are everywhere, because whatever we are talking about, whatever we talk about in microservices, at the backend communication is there. No matter what you might see that, website is doing, but at the backend API would be there. So APIs are also very important. One should understand that how to develop API and how to deploy the APIs with respect to any language that you're working. But at least one should have some exposure that how API works, especially, like, in API world we have a lot of protocols, and we have a lot of lot of things related to communication. But very basic, at least REST protocol, HTTP wise, one should have familiarity that how to develop the API and how to deploy the API and how we communicate, be it through Spring Boot or Django or Python or anything, any backend framework. But one should be able to understand. And then in CI/CD, Jenkins are there. GitHub Action is there. Sonar is there, where you want to improve your code quality in a static analysis way. You want to review your code, you want to see the security and all that one. And then, a couple of other things related to monitoring. Datadog is there, Splunk is there, ELK stack is there. ELK stand for Elasticsearch Log, Logstash Kipana. And then, if you are if you are into that role where you have to come up with some architecture, you have to drive, you have to design, or you have to create some flows, some of the tools you should be comfortable, be it like Lucid Chart, Adobe Express, or Canva, or even Sketchwow. So I use a lot of tools. But if you are in, like, late in career and you have to come up with some flows, you have to come up with some diagrams, so one should be handy with that diagrams as well. API, I have talked about that. No matter what, uh, two A's that are gonna rule the world. One is in artificial intelligence, and second is API. So APIs are everywhere. So that way, at least basic understanding of API is there. But if we are in, if you're in that position where you're drawing architecture or coming up with solutions, then related, not it's not only confined to REST. Other aspect of communication, be it like GraphQL, SOAP, or gRPC, that should also get explored. And from API and integration perspective, as we talked about sync communication and async communications, sync communication is like REST, graph, and all that. And async communication comes into picture, where you have messaging queue, something like Kafka, RabbitMQ, as we talked about. And then if you are into data world altogether, it's a new world. That way you have a lot of things, be it in SQL databases, no SQL databases. So in SQL databases, we know basic databases like MySQL, Oracle, where you are dealing with structured form of information, basic CRUD operations are there. And no SQL databases, like, in NoSQL we have broad categories. We have vector databases, uh, we have document databases like MongoDB, CouchDB. We have graph databases, we have key value pair databases, we have elastic, we have search based databases, we have geomap based databases, we have time series based databases. So list is huge. So based on the requirement, like, some of the databases will come into picture. But at least one should have exposure in a couple of databases if you are into data world. Or if you are in, high in career, and if you want to explore the breadth, so one should have exposure in a couple of databases. And one should understand that in which situation which databases will come into picture. This is the architecture at a high level I'm showing. So in, like, in subsequent sessions or something, I'll try to cover each and every area with the passage of time. And then from from messaging from processing perspective, we have Spark, we have Hadoop, we have Hive, or other things are there. From streaming perspective, not from batch perspective, we have Flink, we have Spark, we have Akka stream, we have we have Kafka stream as well. We have bit of data science. If you're into data science, that's altogether a different game. But if you're in a data science world, and that way, then you should be comfortable with basic data science, and then bit of ML ops, and then bit of generative AI as well. From security perspective, we have a couple of solutions, but this list is not exhaustive. I don't want to scare you all with this complex things. What I'm saying is, based on the domain that you have, based on the experience you have, at least you can pick couple of technologies. But over a period of time, if you want to stay ahead of the curve, if you want to stay competitive in the market, and if you want to rule the market, then you need to get hands on in couple of areas, and you need to get a holds of couple of cutting edge technology, which is very much required to stay long in this game, the way that technology landscape is changing. I'll take a pause. Are we good? Should we move forward? Yes, I'll this I'll recording would be there. Uh, I'll share the content as well. Recording would be there in my YouTube channel. If you have not subscribed to my YouTube channel, you can subscribe to the YouTube channel, and I'll share the PPT. And anything else? So in terms of as we have covered, like, a lot of things are there in this tech. It's not like that one should start in all the direction. Based on the based on the current understanding you have, you can pick few areas, and then you see that first of all you need to see wherever you're working, what are the technologies that are being used, but you don't have that kind of exposure. You try to focus in that way. And then you should also focus that in terms of market, like how market is moving, what are the common areas that at least one should focus, in terms of how someone has to acquire the knowledge, with the passage of time. But that will come with the experience. Now we will move to the next section. So if you talk about at high level, so basically there are many areas in system design, but these are the very basic things which are required for designing any system, be it like availability, scalability, replication is there, caching is there, sharding is there, consistency is there. So these are the very basic core concept. In terms of, if you see, these all requirement falls in non-functional requirement. So when we say non-functional requirement, so functional requirement is what the system should do, and non-functional requirement is how the system should do. So when you say non-functional requirement, given a if you're working in a project, or if you are appearing for an interview where you have been asked that, okay, you have to design a system, you have been appearing for the system design round. So they'll come up with, okay, you have to design a tiny URL, or you have to come up with Twitter, or you have to come up with something, you have to come up with a notification service or something. So the what part would be, let's say we talk about Netflix. So in Netflix, the what part would be that user should be able to play the video, you should be able to search the content, you should be able to like the video, user should be able to maintain a lot of basic stuff. User profile should be there, and favorite could be there, payment related things should be there. And non-functional would be again scalability, in terms of, since we are getting the traffic from all over the world, then how we can maintain that one. And availability is that your system should be up all the time, irrespective of how many users are into the system. Your system should not go down. And then other things related to reliability or consistency. So whenever we go for a system, basically lot many things into comes into picture. So we'll cover few concept today, and then we'll cover few concept in later. in subsequent session. So first we'll cover the scalability. So if you see, are you able to see my screen? This one, are you able to see my screen? Okay. So if you see, we're going to talk about scalability first. The very basic thing is, so when we talk about a big system, when we talk about system design, we don't think in the boundary of a single system. We have to go beyond one system. We have to think of thousands of system. That's what we talk about. But how, like how to start the fundamental? First thing first, let's say now you have been given a task where, let's talk about a very basic problem. Let's say you have been given a task where, what you have to do is, so everybody uses LinkedIn, everybody uses a Twitter. Now what you have to do is, on Twitter everybody tweets. You have been given a task that in last 1 month, if you know how many tweets have happened, let's say millions of tweets are there. So you have been given a task. What you have to see is in last 1 month, how many people are talking about cricket, how many people are talking about maybe our Indian elections. So first thing is, let's say you just have to, given a data, what you have to do is in last 1 month, you have to see whatever the count the tweet had. We had lot many tweets in last 1 month, but you have to count the uh, tweets where the cricket was there, like somebody was talking about cricket, about cricketer. Or you can think of, let's say, focus on the cricket only. So you have to count the frequency of tweet where the cricket was mentioned. Let's say uh, around billions of tweets were there in 1 month. And now you have been given a task. You have to get the data that how many tweets were there where people were talking about cricket. Now for that one, I'm not talking about the logic that what you're going to do. Let's say you have been given one machine. In that machine is a decent configuration. Let's say this machine is around 64 GB RAM is there. In that, let's say 64 GB RAM is there, and this machine is 48 core. It's a single machine. Now, and we are considering that whatever the data that you are talking about, 1 million tweets, it's about 1 terabyte. So if you're not aware of 1 terabyte, 1 terabyte is 1000 GB. So we are just taking a hypothetical example that you had 1 terabyte of data where you had lot many tweets for last 1 month from the Twitter. And you have to process that information, and you have to extract that information, or you have to come up with the stats that in how many tweets people were talking about cricket, or players and anything related to that. We are not talking about the logic that how you're going to do it. So we are talking about that this is the machine configuration. You have a data, and then data processing speed is 1 gigabyte per second. So when I say 1 gigabyte per second, data processing means whatever the distributed framework you are using, or the logic you are using, or the data is in your disk. We are just taking the example that in 1 second you would be able to only process 1 gigabyte of information. Now, if I have to process this 1 terabyte of information, how much time it will take? I'm repeating. So I had 1 terabyte of information, and what I want is, I have 1 month of Twitter data, and one that data size is 1 terabyte, and my processing speed in terms of the program that I'm using or any logic that I'm using, that maximum what I'm able to do is 1 gigabyte per second. So basically 1 GB of information I'm able to process. When I say process, let's say in 1 GB I'm able to make out that 1 GB of data, how many tweets were talking about cricket. Since I have to process this information of 1 terabyte, then according to you, how much time it will take? Everybody clear with the question? Yes, no, or do you want me to repeat the question? Okay, then how much time it will take? I'm waiting for the answer. No, we don't have to think about cores, rams. Simple calculation is, yes, so you need to consider that in 1 GB, uh, we are able to process 1 GB of information in 1 second, and we have about 1 TB of data. So how much time it will take? Okay, someone says 1,000 second, 20 minute, 1,000 second. Okay, so at high level, it's on the right side. So basically, what's happening is approximately, like, in 1 GB, if you're saying 1 second, if we have 1 TB of data, uh, it's 1024. But for the sake of simplicity, we are saying 1,000 second it will take. So with 1 TB of information, if we have to process in single hardware, we need to it will take around 16.6 minute, or about 1,000 second. Now, let's say what we are going to do is, instead of 1 TB of information that we have, now somebody would say that we have to process now last 1 year of data. Problem is same, that we need to come up with the stats, and now the data size has grown from 1 TB to 10 TB, because we had to consume the last 1 year of data, and we have to come up with the number of tweets that were talking about cricket in last 1 year. What we have done is, earlier the disk processing speed was 1 GB, and we have upgraded that speed to 4 GB. Now how much time it will take? I'm repeating. So we had increased our problem from 1 month to 1 year. That's why data size has grown from 1 TB to 10 TB. And what we have done is, we have upgraded the hardware. Let's say earlier we had 64 cores, 64 GB RAM was there, and 148 cores were there. Now what we have done is, let's say we have increased to 256 GB RAM and about 196 core. That's why our throughput has increased to 4 GB per second. How much time it will take? Okay, 2,500 second. Cool. Now, it's not about the calculation that we're talking about. I just wanted to make you understand one concept. So, what we did earlier, the size was on the smaller side. That's why the whatever the hardware that we had, it was able to do it. Now, since we have increased the data size, so we had to upgrade our hardware. And once we had upgraded the hardware, and what we have done is, we are able to solve this problem in 2,500 seconds. So how this 2,500 second is there? So this is 10,000 and divided by 4. So 10,000. uh, so this is 10 TB is 10,000 GB, 4 GB, it is equal to 2,500 second. So in terms of R, it'll come around 41 point, few minutes. Now, if you see, we had only 10 TB of data, and this data processing speed was 4 GB, and it took around 41 minutes. What if I say that we have to do this information for last 10 years? One problem. Second problem is, I want to reduce this time. I don't want to take 41 minutes. I want to take only less than 10 minutes, or maybe 5 minutes. What should I do? I'm repeating, what I've done is, so far we were able to solve this problem, but now I have added few constraints, that I don't want that my system should give me result in 41 seconds just for 10 terabyte of data. And the other thing is, instead of, let's say, 1 year, we had to process for last 10 year. Then what should we do? Partition the data based on year. Okay. Increase core. What else? Upgrade hardware, distributed system, parallel processing. Okay. So some were able to able to point it correctly. So if you see this one, maybe I can upgrade my hardware. There's no problem. Maybe I'll further increase into 256 to maybe 1000 GB RAM or 196 core into 800 cores or something like that. In that way, I might be able to reduce this time. But it may happen that whatever the hardware that I'm, whatever the hardware I'm using, that hardware has some constraint that now I cannot upgrade my RAM, I cannot add more RAM, or I cannot add more core, because maybe the the chipset I'm using or the hardware I'm using, that is not that is not able to support, or the network card that is there, that is not able to support that one. So there is a limit. So basically, when we try to upgrade one hardware beyond that point, you might not be able to upgrade that hardware due to some constraint. So that means there is a constraint that if I want to, if I want to solve this problem in 5 minutes by improving the hardware, I might not be able to use this. And moreover, let's say if I increase the data size from 10 TB to 100 TB or 1 petabyte, this hardware will not be able to store that kind of information. So that means now I need to think from one computing to more than one so I need to think from one computer to more than one computer. So that means I need to go beyond single computing to distributed computing or parallel computing, something like this. Now, earlier we had one hardware. Now we have upgraded that hardware into 10, we have added 10 more servers. Now, if I'll solve this problem, then I'll be able to solve this problem. Earlier, it was taking 2500 seconds. Now it will take 250 seconds. That means I'm able to solve the problem. Now, we talked about two important concepts here. First thing is, when we have a single hardware and we try to improve or upgrade the hardware of that single hardware, we say that we are moving towards vertical scalability. Vertical scalable means that you have a same machine, but you have tried to upgrade the hardware by improving the RAM or improving the network or improving your cores. That is your vertical scalable. So this is your horizontal scalable. Horizontal scalable means when you're adding more machines. So basically, you are not confining yourself into one machine, you are adding as many machines as you want. So horizontal scalability has no constraint in terms of the data or the size. So right now you are adding 10 machine. If you're the whatever the framework that you're using, if it can support 100 machine, it can support 1000, it can support 10,000, as many machine as you want, as you're growing. This is called horizontal scalable. So any system that you talk about in distributed computing, and here when we add more machines, what they are doing. So earlier only single machine was working, whatever the logic that we were running, whatever the program that we had created, from reading the data from Twitter or parsing the data and then filtering the data or making count, that was happening on a single machine using a multi-threaded in core wise. But here the same logic is working parallelly on different machine. This is what we say distributed computing as well, and parallel processing as well. But so far we wanted to focus on the scalability kind of that, what is vertical scalable and what is horizontal scalable, and why distributed computing is important. So I'll repeat. So distributed computing come into picture when we are thinking beyond the when we have a problem to solve where one machine cannot solve that problem, we have to think more than one machine. Or where we have a data size where we cannot store the data in one machine, we have to store the data in multiple machines. Distributed systems will come into two categories: distributed storage and distributed computing. We'll talk about that, but so far we are good. Any questions? Add more compute, optimize the hardware. Okay. No SQL database is couch based. No, I think this is not a problem of database. Couchbase falls in the category of document oriented databases, something like MongoDB. Here we are talking about the processing. We are not talking about storage. Even the storage that we are talking about is NoSQL. It's not NoSQL. It's like we are going to process the data. Though the JSON kind of structure we can maintain in Couchbase, but right now we are just going to process the information that is coming in a way from Twitter. We are streaming that information, and then we need to process that information in real time. For that way, Couchbase will not be a right fit. But yes, other solution we'll talk about. Are we good? Redis cache will not come into picture here. So cache is something in the memory. Cache will not. Cache also has some limit, because cache is usually used where you have a lot of data, and you have databases, and you want to avoid lot many calls to the databases. That's why you maintain a caching layer, and that too you might store maybe 20% of the data from the databases. So caching will not fit here. Caching might be fit for other scenarios, but not here. So are we good here in terms of what is horizontal scalable, vertical scalable, and why distributed systems are coming into picture? Should we move forward? Okay. So now, distributed systems at high level, as the name suggests, when we are going beyond the boundary of one system. So distributed systems falls into two categories: distributed storage and distributed computing. When we say distributed storage, that means that means we are talking about that our data is going to store on a different machine. For example, here, let's say we had to store 10 terabyte of data in distributed storage system. That data would, that for the sake of example, we could say 1 terabyte on each of the machine, but it may vary that some machine use 2 terabyte or some might machine 0.0 terabyte. So we would have lot many machines in actual scenario where we have lot many machines, and we want to store we want to store the data. So usually what happens is, when you're dealing with a distributed storage, you would have a master node and you would have worker node. If I talk about, there could be many things, maybe blob storage like S3 come into picture, or Azure blobs would be there, or Google file storage system could be there, or Hadoop distributed file system could be there. Lot of distributed storage come into picture. But I'll take a very simple example of, since we are dealing with the this thing. So this thing came from Hadoop only, like in 20 years back. This distributed computing. So Hadoop is all about two things: storing the large amount of data and processing the large amount of data. So in terms of storage, it has a system, Hadoop distributed file system, something like, it would have a master node and it would have worker node. So basically, let's say for you have to store a file of 1 GB, and then there is a concept of block. Usually in normal file system, our block size is very small, but in case of distributed system, our block size is on the higher side. For example, by default, let's say the block size is 256 MB. What does it mean? That your 1 GB file will break down into 256 MB blocks. That means four blocks would be there. When I say four blocks, that means let's say your file is there, abc.txt. Let's say this file is there, abc.txt. It is of 1 GB. So when you're actually going to store this file in Hadoop, this file will get break down into four blocks of 256 MB each. So that means you would have four blocks, and these four blocks would be stored on worker node. And in Hadoop terms, we call it data node, but like any distributed system, we could say that worker node. But which file will store, or you could have two blocks here, one block here, one block here. In any system, now how it will get decided that I have to store two blocks here, one blocks here, one blocks here. So you would have a client. Client could be anything, like, let's say there is a client who has to write this file into the system, abc.txt. So it will go to this node, master node. In Hadoop term, it is name node. What it does is, it'll it'll talk to this client, and then it'll provide the information that you can store one block, two block here, one block here, and one block here. So your actual files metadata, when we say metadata, that your block number and file name and everything, that would get stored in master node, but your actual data will get stored in worker node. So if you have 1 terabyte of file, so instead of four, you would have 4,000 blocks. So 4,000 blocks would be, right now you have three machines, maybe 1,000 machines would be there. Now, when we are dealing with distributed system, there are many problems. You had only one system. The problem was very simple, because if you know that system will go down, you'll come to know there was no synchronization was there. You don't have to think, if one system goes, not you don't have to think about other complexities. But when we think about distributed system, a lot of other functionalities or other complexities will come into picture. So it may happen that your one of the worker node goes down, so you have 1,000 machines. If your one of the worker node goes down, then your data might get lost. So this is how, like, these systems have been designed. So by default, they know that if you're dealing with lot many machines, some of the machines might fail. This is a very common thing. So that's why the replication concept will come into picture here. So replication database is different. I'm talking about that is also on the very similar line that you maintain copy. But here what we are doing is, so replication here means where we are maintaining replication factor 2. So when we had original file, we had broken down the file into four blocks, and we have stored this file into this block. Now what we want to maintain is, we want to ensure that if one of the node goes down, we should have some backup. So replication factor is also coming into picture. So here we are maintaining two replication. What does it mean? That we would have one copy this, and one more copy would be there. Let's say another, for example, you had block number 1, 2, 3, 4 is there. So initially, let's say 1 and 3 was stored here, 2 and 4 was stored here. Now you have to maintain the another copy. Then maybe 2 would be there, 3 is here, 1 and 2 would, maybe 2 is here, 1 would be there. But what it will do is, it will make sure that you don't have a same block copied in the same location. So if one of the machine goes down, so this master node, through the heartbeat, will come to know that this particular worker has gone down. So it will ask this worker node to maintain the same replication, and then it will again copy the block. And then this is how this replication will come into picture. So all in all, if you have to store a large amount of file, that file gets break down into number of blocks. Master node or a name node will maintain the metadata of the file, that which block should get stored into which location. And then client will get this information. Once client will get the information, client will make a direct connection with different worker node and will write it. If the replication factor is there, it will internally, the data will be copied to different node, and the replication would be there. So in case of read also, this same practice would be follow. Let's say there is another client, it has to read the abc.txt file. So it will go back to master node. It will come to know that, okay, abc.txt has been broken down into different blocks. It will come to know, okay, my block number is here, block number is here, block number is there. This is how basically the basic distributed storage works. Any question? Are we clear? Sharding will come into database. Once we will discuss sharding, then we'll talk about sharding. Sharding is usually like related with database, not related to distributed storage or something. Though we are maintaining replication, you can logically think of sharding, but actually it's not sharding. In sharding, when we talk about databases, then we'll talk about sharding. Any questions so far? Are we good, or would you want me to repeat again? So if this, two clients are looking for the same data or same block, it does not create any problem, because there is no, like, threading or something. It's still it's like the write would be done by one client, but reader could be many. Once the file is written, anybody could read the data. That shouldn't be a problem. Questions, or if you want me to repeat quickly you can maybe write it yes, or otherwise we can move forward. Are we good? Different node. Otherwise there it will defeat the purpose, because if we are maintaining the replication the same node and same node goes down, then that means we have lost the copy. So the system will make sure that whatever it has to maintain, it will maintain on different node. So are we good? So client is like normal anything who wants to read the data. So let's say you want to store a file, big file, uh, on Hadoop. That means then you are going to interact with the utility or a Java program. Then you are behaving a client. So whosoever wants to write the data that way. So similarly, distributed computing will come into picture, where what it happens is, now instead of storage, you talk about the compute. That earlier the processing was happening on one machine. If you can relate with the same problem, that if I have to, let's make it very simple. Let's say, uh, let's say who will be deciding the replication factor solution? No. So by default, if you go with a Hadoop or something, three replication factor is there. Usually it's a configuration which occurs at the platform level, but you could also decide application wise as well. So this is usually when, when the cluster is there or something, that happens at the cluster level. It's not like those solution architect could define, but usually it is at the org level, where what kind of application that you're maintaining. Yes, you will get this video. uh, what I was saying in terms of, let's go with the very basic, to understand the distributed computing, the same problem. For example, let's say I have to only count the frequency of one day tweet where people are talking about, let's say, Narendra Modi or Trump. Okay, how would you solve that problem? Very simple thing. You have Twitter data, a single day. You have to find the frequency of the tweet. You have to basically get the count of the tweet where Donald Trump was mentioned. How would you do that? Any idea? Any thoughts? Any basic idea, whatever we are thinking, anything comes in your mind, you can think from the programming point of view, anything. You just have to do it. Given a, what you have to do is, uh, okay, I'm repeating the question. So what we have to do is, we get the Twitter data. We are going to get the Twitter data for one day. What we have to do is, we have to count the frequency of the tweets where the Donald Trump was there. Okay. Okay. I mean, I'm not talking about any technology as Spark streaming or Akka stream or Fling. I just wanted to understand the high level logic in terms of maybe how you're going to maintain that one. Very basic thing. We are not going to go talk about this problem, just to make people understand that how distributed system works. Filter by name and count. Okay. So it seems couple of folks are from data engineering. That's why people are talking about filter operation. People are talking about map reduce. People are talking about Spark streaming, batch processing, normal SQL query. The client will not have knowledge of how the design is. Map reduce. Okay. How many of you are from data engineering? because then I think maybe we can quickly cover this one. Because if you are from data engineering, then high level you will be able to know that how these things are. How many of you are from data engineering? Quickly. Okay. Okay. I can see only four answers out of how many folks are there? 31. So rest are from data engineering or rest are not from data engineering? Okay. It seems that we have a mixed audience. So what is going to do is, I'm not talking about map reduce or something. That will be a data engineering topic. We'll cover those topics in future. So I was just trying to understand. I was just trying to make you understand that if you have to, if you have to do this problem, you have been given a data. So from any background you have, from the programming logic wise, what you will do? First of all, you will get the data. You will get the data that, the twitter that data that you will get, maybe you'll get in a JSON or you'll get in a text. So some way you will pass the data. So once you will pass the data, then you will filter the data in terms of that wherever in the text trump is there or in the handle is there, you'll be able to filter out that content, and then at the end of day you'll be able to count the content using maybe maintaining some data structures or something, but you'll be able to do that one. So this is like, when you have a single day of data and you are using your simple program in single machine. Now from distributed computing perspective, you have to think, for example, from one, instead of 1 day data, you have last 365 days or 10 days of data. So your single computer will not be able to work. Now you might have to use some distributed frameworks like MapReduce or a Spark or something like that to solve that problem, where the logic will be on the similar line, that you have to, you have to think about those operation, but your same program will run on different machines. Now once the same logic, you will have filter, you have thousands of machines, you're processing TBs of data, whatever the logic that you have written, that same logic will work on different machines and will do the same thing. And it will keep on filtering the content, it will keep on maintaining the count. This is how your system will work. So actually what happens is, in case of distributed computing, again, most likely if it is a master slave or master worker kind of scenario, you would have a master and you would have a worker. So in case of master, it will just interact with the client, where for us, let's say we had a data of 10 terabyte which we had already stored using the existing distributed storage principle. Now we want to process that information, we want to process that information, and we want to get the count of the tweet where that trump is there. So for that one, you might have to use a distributed framework. In distributed framework, if you're using Spark, then you know that driver will come into picture and workers will come into picture. If you have MapReduce, then other related information will come into picture, where you would have a master and actual jobs would be running on the different workers. So at the end of day, your actual work is being done on different workers, and what they are doing is, so the logic that you have written using the framework, let's say Apache Spark, and then that framework is what it is doing. So you had 1 terabyte of data. To make it simple, let's say 1 GB of data. 1 GB of data you had already stored, and that data is into these many nodes. So you had two blocks here, one block here, one block here, and you have to process this information. So once the program will be submitted through the appropriate framework, it will run on this worker node where it has this information. Block is what? 256 MB block is what? It would have a information. Let's say this information is your 1 million tweets. So you have in 1 GB, you have, let's say, 4 million tweets, which has been divided into three machines, or for the sake of simplicity, let's say four machines. So in each machine, you have 1 million tweets in the form of 256 MB data. Now, this program will run on 1 million records in terms of tweet, and logically whatever the logic that you have read, so one by one it will go and find and filter, will keep on doing that. So at the end of day, it might say that it has 50k records out of 1 million where Trump was there. It will say, let's say 100k. It will say, let's say 10k. And it will say 10k. Not sure what happened. Yes, sorry. So it will say, it will say 10k, it will say 20k. So at the end of day, what we have to do is we have to sum up all of them. In map reduce, like some part of done would be done in mapper, and then reducer would be there. uh, and in normal language, maybe you are doing the filtration, and then at the end of day you are doing the aggregation. So ultimately, your program is running on different machine. Each machine is doing the work, and then finally your framework is giving that you are summing up all the count or aggregating the count. This is at high level. The distributed computing comes into picture. I'm just repeating. What I'm saying is, what we had to do was, for the sake of simplicity, we had 1 GB of data, where in that data is comprising of 4 million tweets, that we have divided into four worker machines. Since we have stored the data on distributed storage, so this data will break down into four blocks. Each block get stored on different worker node, and each block we are saying is about 1 million records. Whatever the program that you're writing, so it will process 1 million records parallelly on each of the machine, and it will be able to filter the data, and it will be able to aggregate. Once it will be able to filter the data from the filtration, for example, it has come up with some number 50k, 10k, 20k. Since we wanted the count of the total tweets in 4 million, so that way we'll sum up all of them. So framework will give you that in next stage you can aggregate all the count and will give the result. Now in between, a lot of things could happen. Let's say this worker node goes down, then that means this master node will make sure that if this worker node goes down, so whatever the data it was there, that data will be copied into some other machine, and then the new machine will, the compute logic will run into new machine, and it will do whatever it is required to do. So are we good? So whatever we are talking about, it's very high level right now. I'm not going to talk about, right now I'm not going to talk about what how Spark is working or how MapReduce is working, because Spark itself is a very dedicated topic, where in future I'll cover Apache Spark and all that. I'm just talking about very raw concept in terms of what is distributed computing, what is distributed storage, when it comes to HDFS, when it comes to Hadoop, when it comes to this one. These are the very deep topic that will demand a dedicated session, and then where those things would be there. But so far, we are good. So far, we are good. Okay. No. So since it will not give the duplicate count, the data is replicated. So data is replicated, but at the back end, when client will talk to the this node, it will come to know that you have to use the block number 1 from here, and block number 2 from here, block number 3 from here, block number 4 from here. It will not use the block number 1 from here, because the it will client will come to know that it has to use this particular node for this block number. If the block that node goes down, then it will go to the another one. Otherwise it will not, it will only read the, one copy. It will not like use that one, that the same file is there or the same replication is there. That kind of intelligent mechanisms are already there in the framework whatever we are using. Any other question? Any basic question about computing, storage, or this one? Are we good to move forward? Yes, or I should again quickly repeat. Since I'm not able to hear you, if I would request if people can comment on this. Okay, so basically if you see at high level, and this distributed computing is very like this master worker or distributed computing is very common. It's not very specific to Hadoop, Spark. Kubernetes also follows this kind of thing, that where you have a control plane or master node. The actual work is done at the worker level in terms of pod and all that, but actual work is been done at the worker level. So master node is just maintaining overall, maintaining that whenever the job is coming, it wants to make sure that whatever the instruction it has given to the worker node, they're able to execute. It will monitor the result, it will wait for the result, and finally give back the result to the client. But actual work is done on the different worker node, and then replications is there, other things related to heartbeat is there if the one node goes down. A lot of other nitty gritty is there, which is there in distributed computing. And same kind of this leader follower kind of thing is also followed in other areas as well. Now, this was all about distributed computing at high level and distributed storage as well. Now we'll talk about high level replication. That what is replication? So it's a very deep topic. We'll cover very few things here, and then maybe we might cover in the future as well. So usually, what replication means? So replication, when we're talking about in terms of database now, most of the database may be it like MongoDB, MySQL, or Postgres, or Redis. You name it, and they have it. Usually, every database has this leader follower kind of strategies, where you have a leader and you have a follower. So what it happens is at high level, usually that you have a client. What it does is, let's say, let's talk about a example of a social media. For example, you have a friend, and that friend is registered on Instagram. Okay, and then at the back end, uh, your friend has changed his profile pic. So I'm repeating that question. This, you and your friends are on Instagram, and your friend has changed his or her profile pic. How will happen in the system? Now what would happen is, if it is a leader follower kind of relation, so first this particular user will interact with the leader. So a write operation would be happening here. So in terms of write, if I talk about at the backend deep, so in terms of if a user is there, so that means at the backend some databases would be there. In database, a table would be there. In table, a table something like user would be there. In user, a particular user, let's say ABC is there. Then and it has changed its profile pic. So something like update command would be sent at the backend, where update set profile ID is equal to new URL, where user ID is equal to ABC. Something like that will be go at the backend, but the write would be happening at the leader level. Now what would happen? Let's say you are reading from this particular node. You are not reading from this particular node, because when you are in when we deal with social media, you don't know now you are reading from which node. So you would have a same instance of the database here. When you were when you visited that profile, since the data was not replicated here, you'll see the old profile, because user has updated the data here. But it may happen now in replication, two things are there: sync replication or async replication. So when I say sync replication, what would happen is, first user is going to write here, and then this leader will replicate the data here. This leader will replicate the data here based on the replication factor. So by that moment, it has not acknowledged the user. Acknowledge the user means, let's say you are going to upload the file. So for you, acknowledgement is when you get the message that your profile has been updated. Until then, you will see that your operation is not successful. So user is going to write in this leader, and leader, in case of sync replication, it will go back to different followers in terms of the same operation it is going to execute there as well. And then follower will send the acknowledgement that it has updated the record, it has updated the record. It may happen that maybe this follower has done it, this follower hasn't done it, but this follower had some problem, it was not able to do it. So if it is not able to do it, and leader had this thing that it has to follow the sync replication, and it has to make sure at least 3 copies should be there. If it is not able to do it, then there would be some time window. Certain seconds would be there where leader will come to know that there is some problem. If follower has not sent the acknowledgement, then leader will send the acknowledgement that your profile has not been updated, because it was required that if it is a sync replication, when you're writing, that record should be replicated here as well. So this is your sync replication. In sync replication, what it is happening is, though it is making sure that you are getting the updated copy, if in your scenario, if there would be a sync replication, if user has updated your profile and replication is there, only then you'll be able to see the new profile. If the sync replication is there, if there is some problem in this one, then actually the profile will not get changed, because user leader will get acknowledgement from these followers that this operation was not successful, and leader will acknowledge back. If the operation is successful, then it will go back and say your profile has been updated. This is sync replication. So far we are good. So far we are good. Okay, I'm quickly repeating. So in case of sync replication, what it happens is, usually in leader follower, first of all, so in leader follower, the write is happen. The write is happen here. Read could happen from anywhere. So if there is another user XYZ, so read could happen from leader, read could happen from here, read could happen from here, read could happen from here. So in if there is a sync replication, in case of sync replication, the user will get blocked until and unless leader will not get acknowledgement from the followers, the operation will not successful. In case of async replication, once the data has been once user has requested to change his profile, leader has committed those changes in terms of updated his database, it will sync back, it will send the acknowledgement, and user will get the acknowledgement that profile has been updated, and user will be able to see the updated profile. But it may happen if it is a async replication, that when a new user was checking the same user on this particular node, it is able to see the old profile because the same data is not replicated. So in case of async replication, the acknowledgement would be sent, but the replication would be maintained at the backend. So your user is not blocked. In async, user experience is getting improved. Your system is not getting blocked, but at the same time, you are not going to get the strong consistency. Eventually, the data would be consistent. That right now, maybe the user is not able to see the updated one, but after a certain time, the same leader will send the data back to replicate the data here in this follower, and eventually the data would be consistent, and this user's profile would be reflected here, everywhere. So this is eventually consistent system when we are going for a async replication. When we are going for a sync replication, we are making sure the system is strongly consistent, but we are compromising on the user experience, and we are compromising on the availability. So you would have heard about CAP theorem. CAP theorem says CAP stands for consistency, A stands for availability, and P stands for partition tolerant. By the way, CAP theorem applicable in NoSQL databases. NoSQL database itself is a big topic, but at high level, NoSQL stands for not only SQL. So that means your data could you don't have in NoSQL, your structure is not as rigid as SQL. I mean, you don't have a structured data. It could have a flexible data, something like JSON or something like in key value pair. And so wherever NoSQL will come into picture, when we talk about SQL, then acid properties comes into picture where you have atomicity, consistency, isolation, durability is there. And in NoSQL, CAP theorem comes into picture. CAP theorem says that consistency means we are talking about strong consistent. Strong consistent means when you are making changes at the leader, uh, and then whosoever is reading from any of the node, you should get the recent data. So in our case, it's like sync replication. Availability means when you are doing any operation, your operation will be successful no matter what. So in this case, in case of sync replication, the availability, we had compromise on availability, because though our operation was successful here, but since the operation was not successful on any of these node, so we had sent the acknowledgement that your profile has not been updated. That means we had compromised on availability. But if we would have chosen the async replication, then we are not compromising on the availability, where the data is reflected here. That's why we have sent the acknowledgement. Though the data is not reflected on these nodes, eventually it will be consistent. That means we are compromising on the consistency. So when we say consistency, it doesn't mean that the system is not eventually consistent. When we are talking about strong consistency, then we are talking about consistency. So in case of CAP theorem, and P is your partition tolerant. Partition tolerant means when you're talking about NoSQL databases, when NoSQL databases means you would have many instances of data, you would have many nodes in the system. So if one of the node goes down, then your system may not get affected. That means if this particular follower goes down, it doesn't mean that my system will not work. It's just whosoever was reading from this follower, now they might read from this follower, but my system will still keep on working. So partition tolerant means if one of my node goes down, still the system will keep on working. If the system will keep on working, that means in NoSQL databases, my P would always be there. Now I have to choose between C and A. If I'm choosing a C, then I'm compromising on C, means again strong consistency. If I'm choosing a C, then I'm compromising on A. If I'm choosing I'm compromising on C. So there are few databases which follows a CP, like MongoDB is there, HBase is there, which is CP. That means strong consistency and partition tolerant by their architecture. AP, something like Cassandra, which gives more weightage to availability because it has a decentralized architecture. That gives more weightage to availability in partition order rather than CP. So in NoSQL databases, if there is any situation, some will follow the CP and some will follow the AP. It doesn't mean that any given point of time they cannot be available or it cannot be consistent. That means if one of the node goes down or there is any problem in the system, now which weightage it has to give. So if in usually what would happen is if it's even a sync replication is there, then in a fraction of nanosecond or something, you'll get the acknowledgement and user will not feel that even the replication was done. Or even in case of availability, that it's not like when you're choosing availability, consistency would be there. But when a situation is there, when there is some problem in the system, basis of these CAP theorem, the different part of the system will behave, whether you have chosen a strong consistency or whether you have chosen a uh, availability. So now, are we good? Are we good? Any question? Any question? Okay. If nobody has a question, so one question for you. So we have lot many topics, so we might not be able to cover so many things today. So we'll maybe cover few more things quickly, and then we'll plan to cover in the next sessions, which we would have most likely every weekend. So if you have not subscribed to my channel, you can subscribe to my channel. And moreover, I run a cohort based course as well. If anybody would be interested, please let me know, and you can register on, I'll share the link, where I take 50 plus hours live sessions on every week. So if any one of you are interested, you can join me there as well, where I go in, cover lot many topics in 40 plus hours live content, covering from generative AI, from data engineering, from APIs, from system design templates, how we have to approach the system design live. So lot many things I do cover. uh, Cap applies to, yes, cap applies to NoSQL only. uh, it totally depends on the situation. If you want a strong consistency, then you go for a sync base. If you want a system where you don't want to compromise on the user experience, you can go for a async one. Usually what it happens is, so if think about social media, what do you think? They are like using a sync or async one? Okay. Okay. More answers? Okay, so basically, like, yes, they are async kind of thing, where because they are not compromising on the availability. That's why whenever we are going for any operation, usually we get a success until unless there is some exception is there. So they are async. Even if they are sync, it may vary. It may vary, and moreover, it may also depend on the kind of kind of operation that we are performing. Let's say we are just writing any comment, we are doing like, or normal thing. So that is not very relevant for the that is not very relevant or very important information. They might go for a async. But let's say you are doing some transaction or something, for that one they might do some sync. So basically it will be a mix of both. But usually for comment, like, and normal things that we see, the day to day interaction that we with social media, usually it's like async. Even if it will be sync, then it will be maybe one or two for a sync and rest for a async. And that too, even for a async, it will have maybe replication for one or two, and then it will do the async for rest of them. So WebSocket and this polling is a different concept that will be applicable for communication, not in terms of databases. WebSocket and usually comes when in the communication, when we are talking about chats or long polling, where we have to maintain a lot of connection. There, these concept will come into picture, not in the terms of databases. Anybody having any other question? Okay, then quickly we can summarize what we have done so far. So replication, and moreover in replication there are a lot of other things as well. First of all, what if this leader goes down? Then how it will be decided? What if the follower goes down? And if the leader goes down, then who will become a leader? And if a follower goes down, or if we have to add a new follower, then what are the strategies? How we are going to replicate the data? Are we going to replicate the data from the how are we going to replicate the data? Basically, are we going to replicate the data basis on log based strategy? Are we going to replicate the data basis on commands? Let's say somebody has written an update command, then are we going to send that update command to each of them, or are we going to whatever the operation it has been done, are we going to send that particular row? So how this thing will come into picture? So basically there are lot many things are there. If the leader goes down, then elections will come into picture, where a lot of algorithms and other frameworks like zookeeper will come into picture, coordination services, where it will make sure that if a leader goes down, then one of the followers will become a leader through a proper election based on the consensus algorithm that you are choosing. uh, or if the follower goes down, then leader will make sure that whatever the replication we had to maintain, that is being followed. If new follower need to be added, then first it will, how it will make sure is that first maybe some level of when we are doing the transaction at the back end, some snapshotting is there, some checkpointing is being happening on the disk level. And then whenever a new follower will come, first the basic snapshotting would be transferred through the network, and then subsequent operations in terms of what happening after that particular checkpoint, that will be sent to a new follower. So there are many strategies at the back end which will come into picture when we are dealing with leader follower. And there are there are systems which are leaderless as well, or multi leader. So when we have leaderless elections, like when we have systems like Cassandra is there, we don't have a leader. They are following a followers kind of, anybody could write and anybody could read. So that way also, it totally depends on what kind of system that you're choosing based on the requirement that you have. If you have to choose availability in NoSQL world, and you have been given whether you have to choose Cassandra, HBase or similar, then you will think that okay, I have to choose for availability. That means I can go for a Cassandra. But if you have to think for a strong consistency, and you are going to go for a document oriented databases, then you look for a similar solutions like MongoDB is there. That way, like we have to choose based on the business problem that we have. Now from the content wise, if you see that scalability, that at high level we have talked about, replication we have talked about, few concepts we will talk later, but at high level, scalability is about we the ability of a system to accommodate increased load or demand without compromising the performance or availability. It's about designing the system that can grow as we are growing as a part of the system, or without major architectural changes. And this could divide into vertical scaling and horizontal scaling. We saw that. We also say vertical scaling is scaling up, and horizontal scaling is scaling out. We saw that vertical scaling has little constraint, that with beyond a point you might not be able to scale a system. Horizontal scaling doesn't have any foundation. Most of the distributed systems are based on horizontal scaling. So based on the need of the need of the system in terms of lot many users, we can add as many machines as we want. And then we had discussed that we have a leader and we have a follower. If we have to write this one, the data would be replicated to different followers, and through replication stream or through queries. And in terms of, there would be sync replication and there would be async replication, where when leader is going, you have a leader and you have a different followers. So if it is a sync replication, what it does is first it will write, and then the change would be reflected. And this leader is waiting that once the follower would be able to send the act, only then it will be able to send the acknowledgement back. So if you see it, first follower done, and then next follower done, what it is able to do, then it is send okay, and then it is send okay. In case of async, it doesn't have to wait. It is able to send the async at the backend, but user is not blocked here. So far we are good. Any question? Any question? Okay. Now, we had also seen the CAP theorem, where we could see that consistency, availability, and partition tolerant. We could see that in NoSQL databases it is being followed, and at any given point of time, in NoSQL databases, either it will be CP or it will be AP. So the normal SQL databases that we talk about, they follow the CA, because partition tolerant and distributed systems are not there. That's why they follow the CA. So these are some of the databases. If you see Cassandra, DynamoDB, CouchDB, they follow the AP. So availability is there. They are compromising with a strong consistency. Systems like MongoDB, Redis, Hypertable, they follows the uh, CP, which is consistency, and they are compromising on the availability. And normal systems like MySQL and all that, they are consistent as well as and the availability as well. So we saw that scenario that any given point of time, either you have to leave the consistency, or you have to leave the availability. You cannot achieve in NoSQL databases, because P you have to use if you're using multiple machines. Now, in terms of system design component, there are many components. When we think about system design, there are many components. Load balancers are there, databases are there. Databases could be many types: new SQL databases, NoSQL databases, SQL databases. Search is there, your CDN is there. CDN is your content delivery network. Distributed storage systems are, monitoring systems are there, your cache is there, distributed messaging systems is there, analytical is there, web server is there, API is there, and many other areas would be there. So when you think about a system design, first thing is you need to cover few known functional requirement that we talked about. Few of them maybe we'll cover later in future sessions. And system design component, that when you think about any architecture or something, you might find some of them or most of them or few other as well. So you need to see if your traffic is coming from all over the world, then you need a CDN. If you know that a lot of requests are there and requests have been bombarded on your app server, you need a load balancer. APIs would be there if you're using a microservices or other. uh, if you are dealing with if you're dealing on cloud, then cloud would be there. If you're dealing with a lot of data on databases, cache will come into picture. If you have a scenario where search will come into picture, you need a search kind of system like a Flipkart or Amazon or Instagram, where you are finding something and then you want that quickly, you should be able to relate that one. So search based systems like Elasticsearch or Solar will come into picture. If you have a system where you have to do a lot of analytics, in terms of you want to capture some matrices, you want to maintain some data warehousing, you want to do a real time analytic, you want to do a batch processing, and then may come up with some stats, then analytics kind of system will come into picture. If we are using real time streaming, then distributed messages system will come into picture. If you're dealing with async communication from microservices perspective, distributed message system could be there. So basically, at high level, if you see at high level, in terms of architecture in system design, first thing is that one should have a fundamental covered in terms of some of the architecture, some of the non-functional requirement, and then the lot of systems component in terms of what is load balancer, how they are working, what kind of different load balancer strategies are there, caching is there, what kind of caching mechanism is there, read, write through, read aside, different caching mechanisms are there. Then you need to think about different databases in terms of whether I need a NoSQL databases and which situation I would choose which database. If you're dealing with lot many communication, sync or async. For sync, you need to decide whether I go for a REST or whether I go for a GraphQL. For async communication, you would go for Kafka or different message, similarly messaging, different messaging queue kind of system. So, and if you're dealing with search, then you will bring Elasticsearch. If you want to do a logging or monitoring, then you would bring ELK or Splunk or so until unless you're if you're not thorough with the each and every component of the system which is required to build the system, you might not be in a position where you can design a system. Once you are able to do that one, then will come into picture that how you have to approach a system design. That first by doing the requirement, and then maybe data bottling or choosing the API, then high level flow, then deep architecture, then low level design, then communication. A lot of things are there, but you would reach to that position until unless you have that background, that each how each component will come into picture. Because if you're going to design a system, if you don't know what kind of APIs that you're using, if you don't know what kind of databases that we're going to create, then it will create a problem. Then you are not sure that how I have to place a load balancer, where API gateway will come into picture, where I have to take the service registration. So that way, first thing is that one should strive to get the component level detail, what these components are there, then their flow, and then it'll come to the architecture at high level, then approaching that system in terms of the estimation, in terms of the other parameters, that if how you have to estimate the traffic, how you have to estimate the volume, how you have to approach step by steps in terms of designing, how you have to come up with basic APIs, how you have to design the data model, then all these things will come into picture. But first thing is getting the foundation. And each component itself is a if you talk about Kafka, if somebody doesn't have understanding of Kafka, that means first one should need to spend some time in understanding the Kafka, that how Kafka works, how it is different from the async messaging queue, what is a Kafka architecture, how we have to interact with Kafka, how you have to how you can how you can work on Kafka. Similarly, how caching is, a different kind of caching will come into picture, what are the pros and different cons of the different caching. So all these things will come into practice once you start thinking about small components and small building blocks. Only then you can think of a bigger architecture, and only then you can think of a approaching any system design. Now I'll take a pause. Any question? Any question? No question. So 100% got it or nothing got it? So I'll plan to cover sessions. It's not like I have to focus on system design. So I'll cover generative AI, I'll cover data engineering. So based on that, I'll keep on covering, but there'll be few sessions on system design. Any question? Okay. Uh, Kafka has a de facto standard. When we are dealing with large amount of data, when we are dealing with real time processing system, yes, distributed queue like Kafka is a de facto standard, because being an open source, that is cloud agnostic. It is present on AWS, it is present on Azure, it is present on Google, and this one. So that way, Kafka is very much important. It's not like Kafka is there. Similar way, just we need to understand that async messaging kind of requirement is there. So we need a solution where messaging queue will come into picture. Can someone become an architect without having deep knowledge in data structure and coding? Um, Coding and data structure at some extent is required, but it's not like that if somebody is not very good in coding, or somebody had not very deep architect cannot become. But yes, until unless, like, if few fundamentals are not clear, then usually we struggle. That's why at least one should have a one proficiency in one language, and basic understanding of data structures. Then otherwise it's not a hard and fast constraint that without that nobody can become an architect. But yes, it's always good to have fundamentals clear, because it's not like in architect you don't have to do some hands on, you might have to do some hands on as well. So reactive programming is different from Kafka. uh, Kafka is a messaging queue. It's not falls in the reactive programming, though it is used in event driven scenario, but it is not falls in the programming, uh, I would say, bucket. So how do we choose the right tool, as it purely depend on the business? Yes. So whenever you have to choose a tool, you have to think of the tech stack, the problem it is solving. Then the obviously it totally depends on the business that you're going to, based on the, it's not like that I have, suppose somebody was asking, do I have to always use the Kafka? For example, in my project, everybody is using some technologies on AWS like Kinesis. Then I can use a Kinesis as well. I don't have to use Kafka. But tool is driven by, first of all, the problem that you're going to solve. And if that there are many tools available which can solve the problem, then there would be trade-off. Whether I can go for a open source, whether I can go for a cloud based, and other factors, or is it like license fee I have to pay. A lot of things will come into picture by choosing this one. How Kafka is different from GCP PubSub? So basically, PubSub is also on the similar line. Kafka is open source, but their terminologies and all that would be different from this one. But from messaging queue perspective, it is on the similar line. No, at high level, I'll talk about HLD. Low level design, I will not talk about. A bit maybe, but the whatever the area that I talked about, the complete thing. If again I'm repeating, if anybody is interested in my course, cohort based course, which will be starting from 4th August, in that I'll cover Kafka and everything, where I will cover this distributed computing, fundamental of all the system components, be it load balancer, databases, whatever I've talked about. And then messaging queue, APIs, cloud tech, generative AI, and tiny URL, Twitter kind of problem, or YouTube, and all those things that I cover, and I plan to cover in that cohort based course that I plan to start from the August 4. Yes, Kafka also follows the leader follower kind of architecture. So Zookeeper manages not creation manage of queues, so topics you could say at the backend. So some level of metadata is being maintained in Kafka, and some broker level of information is also there. Some level of earlier, some level of offset were also being maintained, but now offsets are not maintained at the Zookeeper level. So new version of Kafka that is being maintained at the Kafka level as well, like in the separate topic. So you can let me know in the comments what are the future topics that you want me to cover at high level, and you can also talk about few other areas apart from system design that you want me to cover. Stay updated, and feel free to subscribe to my channel, because from where you will get all the details related to my sessions and other, and moreover, it's not like all the live sessions I'll be conducting. So I'll be start floating some videos as well, where I'll talk about a lot of topics on my YouTube channel. Okay. 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 And you can let me know the feedback as well. So it was very first one, and first live session. So we would have more sessions. Okay. Okay. I'll plan to add more videos. Soft skills are not very specific to this role, but soft skills are required in every role that we have in our industry. Soft skills related to communication, I talked about. If you are striving for an architect, then you should be hands on doing some POCs. One should be a quick learner. some of the operational knowledge that I talked about, uh, at least that is required. Then collaboration is there. Then lot of trade off is there. You have to convince a lot of stakeholders. You need to you should have some negotiation skills as well. uh, and you should be a very good mentor in terms of solving the problem, and in terms of grooming the talent. So these are the basic things that would require as a part of soft skill. Books, it may vary like what kind of topics that you're going to talk about. If you're going to talk about uh, if you're going to talk about microservices, then building microservices is very nice book. I'm not able to recall the author. If you are in data world, designing data application, data intensive application is the must book. If you are dealing with the programming, then cracking the code interview, element of programming interview, that is good. If you are understanding the coding this thing, then clean code is a very nice book. If you are dealing with architecture, then you know a clean architecture and software architect by, I'm not able to recall that one, but I'll plan to share some of the books. Maybe I'll create a dedicated video on the books. I think that will work, where I'll talk about different books on different thing in terms of uh, data engineering and other topic. How to become system architect software developer. It's a journey that will take some time. It's not like I get a lot of question related to like 2 years series. People think that can I become an architect. Trust me, it's a journey that takes time. So at least give some couple of years in your career, try to understand the depth of the knowledge, depth of the area, and then try to cover the breadth, and then you can certainly become an software developer to software architect with the passage of time. Would you like to enter enterprise architecture? So could you comment, say if it would be a cloud engineer to enterprise? I don't, to be very honest, I don't have any much exposure about TOGOF or safe one, but at high level I'll talk about enterprise architecture. And cloud engineer to enterprise, there are, in terms of uh, it, in terms of role, it may vary. That some says enterprise architect, some say software architect, some says it's big data architecture, some says it's cloud architect. But at the end of the day, we have to design solution architect. So there are lot many roles, but at the end of the day, we have to solve the problem. We have to given a problem, we have to come up with the architecture, and given the system constraint, that we have to do that way. I think that will work. For it's not from cloud engineer to our enterprise. Definitely you can move. It's just the skills that I have mentioned that you have to acquire with the passive time. But if somebody wants to acquire the all the skills in a shorter form, then in that case I would suggest you can join my course, cohort based course, where I cover all these things in 40 hours of thing and all the weekend classes. That way you can plan to cover whosoever wants to go into that detail. We do see a lot of content. Yes, that's true that I'm not so regular on YouTube. I started YouTube and then 2 3 months I did. But yes, I love to put more content, and then I would love to see your engagement. Once I'll get the motivation from you guys, when I'll see that people are appreciating my content, and then that will give me motivation that I should spend more energy on YouTube as well. Surely. Recording, I think I'll try to add this video in my YouTube channel. Then once you'll subscribe, then you should be able to see the recording. Though I am though we I'm not sure, this is my very first live session, so I believe hopefully it should be able to give me that option where I should be able to upload. But otherwise I'll see that one. Okay. Keep engaging, keep sharing, and keep sharing your feedback. And if you're liking this session, maybe keep promoting this thing on my other social media as well. That will give me motivation to keep connecting with you guys more and more. So last 2 minutes before we end this session. Okay, if we don't have any question, I think we are good. You can start these members like super, they make them hero from zero. For that one, you would have to join my course, because that is something where I plan to come up with the customized content, and where I have weekend classes. So that way it will be there. For this one, I'll keep on continuing that one, but it may vary that because that is a dedicated course which is 30 to 40 hours, where I have to finish that in maybe 5 to 6 weeks, something like that. But is it in YouTube, it will take some time, where I plan to cover lot many topic, but eventually I'll try to put more content on YouTube as well. But if somebody wants to go very organized and very I would say uh, bit in a hurry fashion in like 6 7 8 weeks, wants to groom, then please join my course. How to practice data structure and coding. Why don't you come up with course in Udemy? I'll plan to cover that one on Udemy as well. A lot of people have reached me out. Trust me, even I didn't want to start my cohort, but a lot of people try to reach me out and requested for the cohort. That's why I had conducted my cohort in the month of February to April last, and then I took a break, and then I'm coming up with this one. Maybe I can plan to record my session, and then I'll plan to put those sessions on Udemy as well in long run. Yes. How to practice data structure and coding. There are a lot many websites are there where you can first maybe first thing is that you should be at least comfortable with coding, and then maybe you can start doing data structure and combination. But if you're struggling with coding, then you should put some focus on the coding, and then you should come to the data structure. Otherwise, lead code is there, hacker rank is there. I would say, if once you'll get comfortable coding and data structure, you should start doing things on lead code, and then it'll take a lot of time, but with the passage of time, you'll see that you'll get a confidence, and then you are able to solve the problem. Everybody whosoever starts on lead code takes time to improve, but apart from using, if you're able to solve the problem, then you should also see other solution as well. You'll get to know their perspective, that how they have solved this problem. And once you'll be able to understand the pattern, that for this problem I have to use this one, for this one you have to this one, then you should be comfortable. DevOps to ML ops. I think first is you should have a basic understanding of ML, then you can move to ML ops. Now ops is at high level, ops is there, but for that one should have a basic knowledge of ML, like what is feature engineering, how we are going to create a model, how this model will run on this, how these APIs will work, how we are going to improve the accuracy. So a lot of things are there, but at least one should have the basic understanding of ML. Only then one can move from ML ops, DevOps to ML ops. But a few things will come into picture, monitoring and all that one, which might get handy. But for that one, at least one basic understanding is there. Only then somebody can move to ML ops. Vice versa, again, if you are into ML ops, then again from DevOps, in terms of basic operation, in terms of containers should be there. You should be good in some kind of scripting language. You should be good in some kind of automation. Then maybe DevOps could be a best fit. In long run, it's not like what is your chair type? What does it mean? And is how to become a good backend developer by practice. Now you can like make a use of Gen AI, like as much as you can on, and then whatever you're lacking, just use the chat GPT or something to improve on that area. But it's a practice that will take a long time. So once you're able to do the practice, only then with the passage of time you can do that one. Basic is first, maybe you can start with core Java, get comfortable with core Java in terms of threading, collections, and all that. Then maybe you can start with Spring Boot and start basic apps in terms of coming up with APIs, and then using the other stacks that way. I don't use much one. This is a normal one, though. Normal. It's not a very special kind of chair, but normal chair like this one. Okay, if we don't have any other question, I think we are good to go. Thank you so much for joining this session, and I look forward to connect with you, some of you in my cohort or in future session. Seems good. Thank you, guys. And if you like this session, maybe you can share on LinkedIn or something, and maybe you can write on the comment once I'll upload the video. Thank you so much for your support. Thank you.